Hello and welcome to the Excel demo of the Scott CPU. I will give a description of the Excel model in which an 8-bit computer is modeled through the book of How Do It Know by John Clark Scott. This is really a great book. I recommend everybody to read it who is a little interested in the exact working of the computers. It's in very simple language, and it's understandable, I think, to almost everybody that reads English. He also has a site, buthowdoitknow.com, and if you like it very much, you can like it on Facebook as well. And if you really want to do some more, you can also ask for a mail with the spreadsheet model in there. I believe John is going to put a download button on there to make the model available. Okay, what we see here now is as much as possible in line with description book. I took a few shortcuts, but I'll get back. Now here we see the three sections that have been outlined in the book, namely RAM and the arithmetical and logical unit, and in the middle we see the control section. Up here we find the general purpose registers used by the control unit, and they consist of 4 registers: 0, 1, 2, and 3. The other registers is the memory address register, which gives the address to the RAM. We see the temporary and bus 1 register, which is needed for the ALU unit. We see the accumulator register, which stores the output from the ALU. We see the IAR register, which stores the next step in RAM. And we see the instruction register. And last, we see the bus, where upon request the control unit can ask for RAM to put something on the bus. Here you can also see these registers in hexadecimal and decimal values, which are easier for you to read. Shifting the spreadsheet a little to the right, we come to the program listing and precompiler. This doesn't actually do anything in a program, it's just a help in writing a part of a program and getting the exact operational codes to put into RAM. So it's a precompiler, and if you look at these first 4 values, you would see that these addresses in RAM, these numbers are similar. I simply copied it from over here with a valid copy statement in Excel to over here, and I can write my programs if I want this way. Right from the program listing, we see the instruction set of the Scott CPU. This is actually the exact same instruction set from the book, and it's actually used to feed the precompiler. So don't take it away if you want to use the precompiler. Last, on the right, a start is made of a video graphics array of 20 by 20 pixels, and it's not connected to the bus, but if you'd like, you can do an exercise and try to connect your computer to this video graphics array. What it will do actually is, for example, I selected some numbers here. If I take her out and you look at the green smiley, you suddenly see that the smiley isn't smiley anymore. It's not working, it's just an Excel facility tool. If you look carefully at the RAM, you actually see the numbers, the decimal numbers 0 through 255. Actually, that's not written in a byte or bit. This is a trick I use in Excel. It's not necessary. I also have a version in where I can store the bits I have a picture of that below, but then I need so much space in my Excel sheet and it gets slower, and it doesn't help showing the demonstration value of the program. So I use the simple byte store for the RAM. Well, now coming to the operation of the spreadsheet. I zoom in and I'm going to put it like this. What we see here is a couple of buttons that you can use. You can either tick, which means is a quarter of a clock step. You can step, which is an entire clock step, or you can cycle, which is 6 steps or 1 instruction cycle, as it's called. In addition, you can run at different speeds. The higher the value, the lower the speed. Or you can fast forward through the program if you're curious to results and you want to test the program instead of seeing how it exactly works. I'm gonna put in the tick. If I press this, it goes 1 tick ahead. You see this 0 going to 1. And what you see is this red line lights up. So actually it's putting this address on the MAR to get the next instruction. I can tick through it like this, and you see the various lines activate: red, green, or purple. I can also say I take a step, so that's 2, 3, 4. Here you see the steps down there, the ticker. I'll take another step, it will go to step 4. Hey, and here we see some blue arrows, and these help you indicate that this point activates the MAR in this case, and the bus 1 in the other case, and over here the IRR is enabled and the accumulator is set. Well, I can also do an entire cycle. Here we go. So we were at step 4. And now it's back at step 4 and it will stop again. Okay. The 4 means actually 4/10 of a second. If I go too fast, if I to a fast mode, then what you see will happen is it will go fast through the program, and I'll let it run until completion. The program that it's running is the multiplication of 2 numbers, which is in the book as an example. I only added 3 statements to get data. Byte number 1, 5, and byte number 2, 25. If I multiply these, the value is stored in address 22. Well, it's finished now. It's in an infinite loop, going back to itself all the time. So I can stop the program by pressing either escape or break. Then the Microsoft Visual Basic ends up, and I just click end, and ready to go. I don't need to reset or do anything else. I can continue with run or fast or tick or cycle, anything. What we see here now is the value 125 has been placed into this memory area, which is actually the result of 5 times 25. Just to show you that the program has really done it, I can change this value over here. I can reset the program. Yeah, I want to reset. So now it's 5 times 50. That should be 250. And I do the fast forward again. Letting it run until completion. And there it is. We end by either control break or escape. Now we see that the value that has put in there is 250. So the program seems to work correctly. One last hint: if I use fast and I change this number over here, 1 means that it runs a tick very fast. 2 means it runs a step very fast. 3 means it does half a cycle very fast. 4 means it cycles through an entire cycle fast. I like this the best because it gives you the best demonstration. But you can also go to 2 cycles, 3 cycles, 4 cycles, etc. to see what happens. Okay, I'm going to reset it. Okay, and I'm going to show you the overview now of how it runs. I'm going to zoom to 75%. That seems nice, and just let it run at 2/10, and just like that. And what you see is the different lines lining up, and actually it's just performing as a regular computer. I promised you 2 tricks I did. One trick is, I'm going to stop the computer again. The first trick I do is I have a counter here which I set within a Visual Basic macro, which runs from 0 to 3 and then back to 0. It keeps on counting. The clock and delay depend on this value, but that's all the manipulation I do in macros. There are some other macros there, but these are just there to show the lines, to reset, and to run in various modes. Well, I wish you good luck. I hope you liked this video, and be sure to visit the site of Mr. John Clark Scott.